DiPP is our diamond pilot plant facility. It's a major operating pilot plant or series of pilot plants that we use for education and research in chemical engineering at the University of Sheffield. The facility consists of several pilot plants. Our largest is the powder to tableting plant, which you can see behind me. We also have bioreactors at several different scales. We have a continuous crystallizer and continuous filter dryer facility for processing materials, and in addition we have what we call the Power to X, which is producing liquid fuels from carbon dioxide. So these pilot plants represent state-of-the-art technology in modern chemical engineering.
The continuous tableting line effectively turns pre-blended mixture of powders into tablets. The line starts off with a blend of powders in the hopper. This hopper is gravimetrically controlled and measures loss in weight and feeds into our twin screw granulator. Our twin screw granulator turns this powder into granules by adding a liquid binder and applying high shear forces to the powders, which turns them into wet granules. The wet granules then fall into our 6-chamber fluidized bed dryer, which dries our granules. From the 6-chamber fluidized bed dryer, the granules are pneumatically conveyed to our granule conditioning unit, which measures the moisture content of the granules using a near-infrared moisture probe to determine that the granules are within specification, and then mills the granules to narrow the size distribution. The granules can then have an external material added to them using another gravimetric feeder before, again, the granules are pneumatically conveyed to our press preparation units where magnesium stearate lubricant is added. The granules then drop into our tablet press where we apply high forces to the granules to turn them into tablets. Our bioreactor suite consists of 2 pilot-scale bioreactors, one 7.5 litre bioreactor and another 30 litre bioreactor. These bioreactors allow us to use microorganisms as miniature factories to produce high-value products. Each bioreactor has a series of sensors connected to it, varying from things like pH and temperature to things like viable cell density and total cell density. These sensors allow us to determine the growth rate and health of the microorganism cultures within the bioreactors.
We've engaged with industry from the start with the facility, and we see this as very much an active collaboration. And there's really 2 key areas. One is in training and one is in collaboration and research. So in training, we already offer bespoke training courses for some companies who bring their engineers and operators here to learn about the practicalities of operating the continuous manufacturing equipment. In terms of research, we have many research partnerships with companies at many different levels, from master students projects through to PhD sponsorships through to major collaboration on large research grants. So we've got an industry university ecosystem running around the pilot plant that is something that we're already proud of but keen to expand and engage with new partners.